Today we're going to be talking about trapezoids and kites. Our objective is that we'll be able to use the properties of trapezoids and kites to solve problems. So, some of the properties of a trapezoid is that it has one pair of parallel sides. And these parallel sides are called the bases. So, in this picture, this side is parallel to that side. So this would be a base, and this side would be a base. But they don't have to be the top and the bottom. If it was turned sideways, and these two were parallel, they would also be the base. So it's whichever sides are parallel. The other sides are called legs. As far as the angles go, mark those parallel, there are two pairs of consecutive supplementary angles, and they're going to go from one base to another. So if this angle is 100, and then this one's 80, or these two together would add to 180 degrees. Then there's a special type of trapezoid called the isosceles trapezoid. It still has bases that are parallel. However, the legs are congruent. So congruent legs. In an isosceles trapezoid, the base angles are congruent, meaning the angles touching the same base. So this angle and this angle are congruent. This angle and this angle are congruent. And then the diagonals, let's try that a different way. That diagonal and this diagonal, they don't bisect each other like they did in the parallelograms, but they are the same length. So this piece and this piece would be the same, and this piece and this piece would be the same. So they have congruent diagonals. So let's put these properties to use. Find the angle measures of ABCD. So we know that angle A and angle D are consecutive and they will have to add to 180. So 180 minus 91 leaves us with 89. So therefore the measure of angle D would be 89 degrees. We can use the same idea to find angle C using angle B. 180 minus 132 leaves us with 48. So the measure of angle C would equal 48 degrees. Number 2 is an isosceles trapezoid. So we know that the angles along this base are the same, and the angles along this base are the same. So we know that the measure of angle B would be 53 degrees because it has to be congruent to angle A. Angle D and angle A are consecutive, so 180 minus 53 degrees equals 127. And we know D and C are congruent, so the measure of angle D It's going to equal the measure of angle C, and they're both going to equal 127 degrees. Now trapezoids have a special part of them. It's called the midsegment. It is a segment that connects the midpoints, or the midpoint of each leg. So these are our parallel sides. So these are our legs. Let's say the midpoint's here, and the other midpoint's here. So those connected, that's the midsegment. It is parallel to the bases, and its length equals the first base plus the second base over 2. It's the average of the bases. So in example number 3, base 1 is 28 plus the second base of 22 over 2. 28 plus 22 is 50 over 2, which means our midsegment is 25. In number 4, there's 2 different ways you can look at this. You could say 12, because that's the midsegment, has to equal 3x minus 1 plus 16 over 2. Multiply the 2 to both sides, we get 24 equals 3x, and I'm going to combine like terms to get 15. Subtract 15, we get 9 equals 3x, so x would equal 3. Another way of doing it is from 16 to 12, we subtracted 4. So to get from 12 to the top base, we would also have to subtract 4. So we know that AB has to equal 8. So we know 3x minus 1 equals 8. 3x equals 9. So x still equals 3. 2 options to solve the same problem. Let's look at some kites. Kites have 3 special properties. The first is that it has 2 pairs of consecutive, remember that means next to each other, sides, and these are congruent consecutive sides. So this will be congruent to this because they're next to each other, and this will be congruent to this. In between those sides, this angle here and this angle here, they will be congruent. So one pair of congruent opposite angles. And our third property has to deal with the diagonals. Looking at those, what do you think is true? I know mine's not perfect. They are perpendicular. So let's use these ideas to help us out. Solve for x and y. Well, let's start with x because those are the sides in between the two different sides. Since those angles are congruent, 2x plus 1 has to equal 135. 2x would equal 134. So x equals 67. So we know this angle is 135 and this angle is 135. But how are we going to figure out what y is? If you think back, we've talked about this a couple times, the angles in a quadrilateral add up to 360. Remember when we did n minus 2 times 180 and our polygons unit? 4 for 4 sides minus 2 is 2 times 180 means a quad has angles of 360 degrees. So 360, we already have 135 twice, which leaves us with 90 degrees. So that means y plus 6 plus 5y has to equal the 90 degrees that are left. Combine like terms, 6y plus 6 equals 90. Subtract the 6, 6y equals 84. Divide both sides by 6, y equals 14. Finally, let's use the diagonals to help us find the missing side length. So, since these are right triangles, we can use the Pythagorean theorem. And remember, we already know that MA and MH are the same, and that AT and HT are the same. So let's make MA x. We know that x squared equals 6 squared plus 5 squared. So x squared would equal 61. Square root both sides. X equals the square root of 61, which can't be simplified, so we know that MA, which is equal to MH, is equal to the square root of 61. Let's make AT y. We would know that y squared equals 5 squared plus 8 squared, which means y squared equals 89. Square root both sides. We get y equals the square root of 89, which also cannot be simplified. So AT, which equals HT, equals the square root of 89. Finally, for your summary, write about how kites and trapezoids are similar to the parallelograms we've learned about and how they are different. That's all for today. See you in class.